Hello my friends and welcome back to the You Can Do TV channel. Universal casting beds at Moldtech span meters to accommodate multiple beam sizes efficiently. Didn't expect the anchor grips to lock so seamlessly. This is satisfying in its own way. The process begins by positioning the reinforcement and laying the tensioning cables. Alternating carefully between these steps ensures the structural integrity required for high-performance beams. Next, the active stressing head is prepared by placing retaining rings into the slackening cylinders. The anchor grips for the cables are inserted, followed by tensioning to exact specifications. Feels like this machine doesn't waste a second thinking. Once tensioned, stoppers are sealed and lateral molds are positioned, activating the anchoring system to secure everything in place. Concrete is then poured into the molds. Its flow fills every corner, ensuring uniform density and strength across the element. After the concrete hardens sufficiently, the surface is cleaned and release agent applied, preparing the casting bed for the next piece. Inline production continues, reiterating the cycle along the length of the bed until the entire run is completed. That pull on the tensioning cables is stronger than you'd think for a mid-size setup. Moldtech employs various systems to adapt to project needs. The multi-base system allows interchangeable base plates with height adjustments, while fixed base plate setups support multiple widths with universal plates. Lateral molds are multi-position, enabling precise shaping of beams such as T-beams, rectangular beams, and delta beams. Each piece is tailored for structural demands in public works, industrial, and residential projects. Throughout, the combination of human operators and automated equipment ensures speed and precision. That setup feels like muscle and intelligence packed together. The modular design of the casting bed and stress equipment supports a wide range of pre-stressed elements without compromising quality. Every step, from reinforcement to final concrete placement, is monitored and adjusted to maintain consistent results. By the end, pre-stressed elements emerge ready for transport and installation, exemplifying the careful engineering and flexibility Moldtech integrates into every casting bed solution. This is why precision in pre-stressed concrete production matters so much. How do technicians guide 40.8-meter PCI girders safely onto piers at the Trans-Sumatra Toll Road project? Every crane and sling is inspected multiple times before lifting to prevent even minor failures. That pull looks stronger than you'd expect for such a slender structure. Safety is paramount in girder erection, and every step follows strict procedural requirements to prevent accidents. Load calculations are double-checked to ensure no unexpected stress occurs. The operation begins with the placement of cranes and rigging equipment at precise locations. Slings are attached to the girder ends, ensuring even weight distribution. Technicians check all anchor points and connections. Engineers verify the rigging angles to avoid tilting during the lift. The coordination here feels like a combination of muscle and calculated intelligence. Once the girder is secured, the lifting process is initiated. The crane operators communicate closely with the ground team to guide the girder into its designated position on the piers. The lifting is gradual and steady, minimizing any swing or rotation. Each movement is tracked with measuring devices to maintain accuracy. That alignment step is critical. Misalignment could cost hours of adjustment. As the girder hovers above the pier, temporary supports and guide systems are engaged. Workers on site attach the girder to these supports, confirming that the load is properly transferred. Anchor points are tensioned sequentially to distribute forces evenly. Kinda surprising how smoothly the girder slides onto the pier with all that weight. Next, the team carefully adjusts the girder to match the design elevations. Hydraulic jacks and leveling tools are used to make fine adjustments, ensuring the top surface aligns perfectly with the roadway profile. Bolts and fasteners are inserted to secure the girder in its final position. Alignment marks on the pier help verify precise placement before final securing. After all structural checks, the lifting equipment is released, and the crane is prepared for the next girder in line. The cycle repeats until the entire section is completed. Ground crews perform final inspections of connections and temporary supports to ensure stability during the remainder of the construction process. Inspections include visual checks and torque measurements for each fastener. That sequence looks deceptively calm for such a high-risk operation. Documented procedures are referenced constantly to ensure compliance at every stage. Redundant safety lines are sometimes used for added protection during critical lifts. Throughout the erection, communication between crane operators, engineers, and ground personnel is continuous, allowing immediate adjustments if any deviation occurs. The combination of prefabricated PCI girders and careful handling accelerates construction while maintaining safety. This shows why following procedures precisely matters as much as the machines themselves. By the end, the 40.8-meter girders are fully aligned and secured, forming a critical segment of the Trans-Sumatera Toll Road. Each girder reflects the careful planning, engineering expertise, and teamwork required for high-rise infrastructure projects. You wouldn't guess that such a delicate maneuver carries this much potential energy. It's rare to see a press base this massive assembled with such fine detail. Feel the scale of precision and power as the PMA Speed Ram HP 1000 is assembled at FIME Group's Vigano facility. It's wild to see thousands of kilos of steel getting positioned like a giant puzzle. Every cubic meter of poured concrete is measured to guarantee the machine's stability. The foundation excavation ensures the press will operate safely under full load. The site is a hive of activity, preparing the foundation for this high-performance hydraulic press designed for the demands of Industry 4.0. Excavation covers 545 cubic meters of earth, clearing the space needed for the heavy installation. Engineers confirm excavation depth and alignment before proceeding with reinforcement. The sheer volume makes you wonder how fast the site crew can keep up. After digging, demolition crews remove 230 square meters of old concrete flooring to make way for a new reinforced structure. Steel reinforcement layout is double-checked against design plans to ensure load capacity. Steel reinforcement totaling 20,000 kilograms is carefully set in place, forming the skeleton for the concrete pour. Concrete delivery follows a strict schedule, with 423 cubic meters poured to create a solid base capable of supporting the massive hydraulic press. Technicians ensure each layer is level and secure. That pour looks like it could take a small lake to complete. The first action in the assembly involves positioning the base frame of the Speed Ram HP 1000. Heavy-duty cranes align the frame with millimeter precision. Bolt torque is verified using calibrated tools to meet engineering standards. Steel bolts and welding points are checked multiple times to ensure stability under operational stress. This setup feels like muscle and intelligence packed together. Hydraulic cylinders are next, installed with care to guarantee alignment. Each cylinder is calibrated to deliver uniform force across the press. Engineers monitor the torque and pressure settings thoroughly, verifying that the machine meets exact specifications. Cylinder positioning tolerances are within a fraction of a millimeter. You'd never guess a machine this massive could be so finely tuned. Mechanical components, including the ram and its guiding system, are carefully lifted into place. Pneumatic connections and lubrication systems are integrated simultaneously, ensuring smooth operation from the start. The final task involves comprehensive testing. The team runs trial cycles to ensure the press operates within its parameters. Safety checks confirm that all systems respond accurately to commands. Didn't expect the Speed Ram HP to move so smoothly considering its size. Trial cycles confirm uniform pressure across the entire press surface. The FIME Group crew completes the installation efficiently, combining engineering skill and heavy machinery coordination. By the end of the time-lapse, the PMA Speed Ram HP 1000 stands ready, a testament to precision engineering and Industry 4.0 capabilities. Kind of funny how the massive steel suddenly looks elegant once it's all in place. From excavation to testing, every step highlights teamwork and mechanical excellence, making this installation as much a performance as a construction project. DN 3270 and DN 3000 sections are laid out for a multi-chamber drinking water tank in Lutzen. Each DN 3000 pipe section is engineered for tight connections that guarantee leak-free performance. Installation is streamlined, allowing later expansions with minimal disruption. UV-resistant materials protect the system against long-term weathering. The project in Lutzen showcases a multi-chamber system with crosswise sliding gates, enabling controlled water flow management. Individual access points and entry options provide flexibility for maintenance. Simple, fast laying methods reduce installation time while ensuring compliance with all drinking water standards. Integrated fittings and control technology optimize monitoring and operation. With project-specific GFK solutions, the system adapts to diverse site requirements. It's impressive how these components interlock with such precision. Blue pipes demonstrate how modularity, durability, and smart engineering come together to support sustainable water infrastructure. You can almost see the system anticipating future upgrades.
At Califort, the Xblock prefabrication unit produces thousands of concrete blocks for coastal defense. Each Xblock, designed to withstand storm surges, starts life in carefully organized zones of aggregates and prefabrication. The storage area holds raw materials before they are moved to the production line, where massive molds shape the blocks. A stacker transports the freshly cast Xblocks efficiently, ensuring continuous workflow. It's fascinating how each block is a puzzle piece in a structure meant to resist the sea's fury. The laboratory zone constantly monitors material quality, while the gyroscopic cells ensure each Xblock's balance and stability. Seeing the precision applied to blocks that weigh several tons is jaw-dropping. Aggregates are combined in precise ratios before casting, creating a product capable of absorbing wave energy and preventing coastal erosion. Each step, from mixing to casting and transporting, is choreographed for efficiency and durability. Almost comical to think these concrete giants will face relentless ocean waves. By the end of production, the Xblocks are ready for deployment along Calais, new seawall, totaling 16,000 units. This is large-scale civil engineering in action, turning raw materials into protective fortresses. The combination of mechanical automation and human oversight ensures every Xblock meets strict safety and design standards. Who knew concrete could be so strategic and fascinating?
Massive blocks of marble emerge from the Grupo Galrao quarries, each piece reflecting years of geological history. Tons of marble are moved every day, requiring precise teamwork and planning. Workers navigate rugged terrain with skill, moving stones that weigh more than a small building. Estremos Branco, Picasso, Amadeus, and Rosa Aurora marbles are carefully extracted, highlighting both the natural beauty and structural quality. Cranes and forklifts coordinate seamlessly, lifting each slab with millimeter precision. Cutting and polishing operations follow, turning raw blocks into usable slabs while retaining their unique veins. The marble here almost feels alive, each pattern telling a story of nature's design. Logistics crews transport slabs to storage areas, ensuring the material remains intact and protected. It's amazing how teams handle these massive stones without damaging their delicate surfaces. Quality inspections confirm that every slab meets structural and aesthetic standards. Seeing the Rosa Aurora being prepped makes you think of a giant sculpture waiting to happen. Administrative and technical staff monitor every step, ensuring workflow efficiency and safety. These operations look like an orchestrated balance of power and finesse. By the end of the day, the quarries reveal both the human effort and natural artistry behind every marble block. Couldn't imagine the scale of this work without witnessing it in person. crew and drum spin in sync, turning heavy concrete work into smooth flow. At 24 feet wide, the custom Flume drum provided Realm Construction Inc. a new level of efficiency. This 1,000 pounds drum with 8-foot wings and an 8-foot pan carried more than just weight. It carried time savings. Pulled along by cable trolleys on both sides and powered by the hydroscreed, the drum's spinning action brought cream and fat to the surface and pushed aggregate down without slumping the sides. That continuous motion prevents the small inconsistencies that usually plague flume pours. Approved by the Missouri Department of Transportation, it allowed a continuous pour that eliminated construction joints, doweling, redundant cross-forming, and downtime after rain. Minimum of 600+ man-hours saved on this one job alone. This setup is ideal for cost-effective placement of small to large ditch paving and concrete flumes. The new retaining wall ensures hillside stability and protects against erosion. A 25-meter retaining wall is replaced piece by piece with 180 centimeters high elements. The terrain is tricky, and every L-shaped element must be placed with care to ensure long-term stability. Each segment must fit perfectly, or the wall's integrity is compromised. The team removes the deteriorated wall, clearing space for a high new structure installed. Watching these massive elements being positioned almost feels like assembling giant building blocks. Cranes lift each piece into place while operators adjust alignment and leveling. Even small misalignments could cause big problems later, so constant checks are vital. Backfilling follows, compacting soil behind the wall to prevent future erosion. The crew handles both earth and concrete like a well-coordinated machine. Anchoring and interlocking connections make sure every unit supports the next. You wouldn't think a 25-meter structure could be moved so smoothly piece by piece. Site engineers monitor measurements and verify stability throughout the process. The coordination here shows that teamwork and engineering expertise go hand in hand. The time-lapse condenses hours of coordination into a visual story of teamwork and engineering skill. Finishing touches include checking angles and reinforcing any weak points before opening the site. It's oddly satisfying to see the wall rise steadily, a silent testament to careful civil engineering. By the end, the hillside is secured, combining structural integrity with the elegance of methodical installation. Never realized that a seemingly simple wall replacement involved so much planning and muscle. With a telescoping frame extending up to 16.5 feet wide, the GMO GP 2400 handles concrete paving efficiently. Operators adjust the width seamlessly, fitting the paver to different lane sizes in seconds. Concrete is loaded into the hopper, and the machine advances steadily along the prepared subgrade. The Slipform system shapes the concrete while maintaining consistent compaction and surface finish. Vibrators and augers distribute and consolidate the mix perfectly. That smooth surface saves hours on manual finishing. Curb and gutter sections are simultaneously formed using the integrated mold attachments. It's amazing how one machine handles multiple tasks at once. Screeds follow closely, adjusting automatically to variations in grade. Ground crews can monitor the process without constant corrections. Expansion joints and finishing touches are applied as the paver progresses. This setup ensures long-lasting, high-quality pavements. Feels like the road is being rolled out like a carpet. Once the section is complete, the GP 2400 is retracted and repositioned for the next pour. Every cycle cuts time and labor costs dramatically. The combination of width adjustment and slipform precision is just genius. A new airport hangar at Wellington needed a floor that could handle extreme loads, and Firth took on the challenge with skill and coordination. The scale of the slab makes you realize just how much planning goes into airport construction. The engineering behind each cable layout ensures every square meter carries the intended load. Technicians position the reinforcement carefully, ensuring structural integrity. Seeing the reinforcement laid out makes the complexity of the slab obvious. Concrete trucks arrive in sequence to maintain a continuous flow into the molds. The crew uses vibrators to consolidate the concrete, eliminating air pockets. The coordination between trucks and crew keeps the pour seamless. Chutes and tremies guide the concrete precisely to the corners and edges of the slab. As the concrete spreads, crew members monitor the consistency to prevent segregation. Rakes and screeds are used to roughly level the surface immediately after placement. High-capacity hydraulic screeds smooth the concrete to near final grade. Edges are formed and compacted to maintain alignment with the intended profile. Curing compounds are sprayed to minimize surface cracking. Additional hand finishing ensures tight areas and around embedded fixtures are properly filled. Every section is checked to ensure no weak spots before moving to the next pour. The cycle repeats along the casting bed until the full slab is completed. It's impressive how the workflow keeps the concrete moving efficiently across such a large area. In just 10 hours of work, the hangar floor rises with precision and power. Truly remarkable how planning, tensioning, and pouring come together so smoothly. The result is a robust, reliable foundation that will serve Wellington Airport for decades.
Thick layers of mud and debris are no match for the Prestressed Panther T14R as it tackles the Sorum Quick Clay landslide. The rotatable dumper box allows operators to reposition loads efficiently, optimizing cleanup operations. That dump looks more like a controlled avalanche than a machine at work. The team directs the Panther T14R across unstable terrain, carefully depositing extracted soil into designated areas. Each rotation of the dumper box maximizes the volume moved while maintaining balance on the slippery surface. Simple hydraulics, yet the power on display is undeniable. As the vehicle progresses, larger chunks of clay are broken down by the tracks and guided into manageable piles. Operators coordinate maneuvers to prevent equipment from sinking into saturated ground. The Panther's tracked undercarriage distributes weight evenly, allowing access to the most treacherous sections of the landslide. That pull could make any ordinary machine give up instantly. After each load is repositioned, attention turns to smaller debris, ensuring thorough removal and stabilizing the area for future safety. Rotating the dumper box with precise timing allows continuous workflow, avoiding unnecessary delays. The combination of tracked mobility and rotatable dumping demonstrates the Panther T14R's capability in disaster recovery. Every movement contributes to an efficient, safe, and sustainable cleanup effort.
Bridges, ramps, and siphons align to shape the flow of Kachi Canal from RD 1286 plus 000 to RD 1322 plus 000, forming a vital irrigation system. Superpassage 1 is laid out precisely at RD 1288 plus 450, guiding water efficiently. Village Road Bridge C links local traffic seamlessly while construction progresses. DISTY22 and RD 1292 plus 400 mark key sections with reinforced PCC lining to secure the canal structure. Superpassage 2 ramps take shape with stone detailing, ensuring durability. Grades. Siphon-I at RD 1305 plus 000 channels water beneath terrain obstacles with robust engineering. Cross-regulator at RD 1310 plus 500 is integrated to control flow rates accurately. Excavation of the escape channel at RD 1322 plus 000 completes the alignment, allowing excess water to drain safely. The scale of coordination here looks like a carefully planned giant puzzle. Each segment reflects structured engineering, teamwork, and attention to long-term performance. Hard to believe such massive earthworks come together with such flow efficiency.
Trailers carrying over 20 tons release stone layer by layer on the ground. Drivers coordinate with ground staff to guide the material, ensuring each pile is shaped correctly. Bright red side dump trailers tilt laterally, pouring tons of crushed stone onto the construction site. Each trailer bed is built to handle extreme loads without structural deformation, even under repeated lateral tilts. Hydraulics lift the trailer beds sideways, letting the stones cascade efficiently from the open side panels. That stream of rocks flying out looks oddly like popcorn in turbo mode. The hydraulic cylinders are rated for hundreds of cycles per day, ensuring consistent lateral dumping throughout the shift. Feels like the machine doesn't pause for a second. Everything moves with raw force. Gravel spreads gradually, forming a stable foundation for the next stage of construction. That pull is stronger than you'd think for a mid-sized machine. After each lateral dump, trailers are repositioned and the process repeats seamlessly. The side dump design allows quick unloading while minimizing repositioning. The trailer frame geometry is optimized to prevent stone bridging and ensure smooth flow at every tilt. Simple mechanics, but serious strength at work. Human oversight combined with hydraulic precision guarantees uniform results. Safety measures keep workers at a safe distance as machines operate efficiently. The finished area receives a consistent layer of gravel, ready for paving or subsequent construction tasks. That setup feels like muscle and intelligence packed together. The teamwork and engineering behind each lateral dump demonstrate the power of modern side dump trailers. Somehow, the whole process looks almost too easy for what it's doing. From the hydraulic lift to the controlled flow of stone, every component is designed for efficiency and durability under demanding conditions. Setting up the Patriot Energy rig shows how tight each step fits together on the cleared pad. Crews frame the 6x6 hole, seal the mud pit, and run the starter rig to drill the first 40 feet. That burst of dust feels unreal for such a small machine. Casing is lowered, and cement locks it in place. That little rig pulling big duty hits unexpectedly. Built to lift extraordinary loads, the Liber LTM 11200NX is assembled at JR Sasaguri, even while massive steel parts still need delicate alignment. This all-terrain crane arrives in sections, and each component is handled to build the machine's full lifting capability. That moment the carrier rolls in already feels like raw potential waiting to move. The first actions center on positioning the carrier frame so the setup area stays stable under the crane's 1,200-ton class structure. Outrigger pads are aligned, extended, and leveled to create a reliable base for the upper assembly. That stance the crane takes once the outriggers settle looks surprisingly confident for its size. Next comes mounting the slewing platform and engine module, joined so the upper structure can rotate under full control. Hydraulic lines and electronic systems are connected section by section, allowing the crane's safety systems to activate. Feels like the whole machine is waking up one circuit at a time. Boom assembly follows with transporter trucks bringing each segment to the crew. The lower boom is pinned first, followed by intermediate sections guided into place under precise signaling. The final boom element locks in so the crane reaches its full working length. Jib components arrive last, giving the crane extra height for the bridge walkway installation planned after trains stop for the night. When everything aligns, tests confirm load control and rotation accuracy before the job proceeds. The way it lifts during testing almost feels like watching strength learn its own balance. With the LTM 11200NX fully assembled, the night shift gains the power needed for the crossover bridge installation.
When a hulking Cat D10T2 chassis rolls onto the assembly floor, the mainframe lies inert, heavy steel waiting for life. The sheer weight of this chassis demands precise alignment at every step. At this stage, workers begin installing the massive undercarriage. Track frames are aligned, track rollers and elevated sprockets are bolted into place so the final drives will sit high to avoid damage during heavy-duty dozing. Each track roller must meet exact tolerance to prevent uneven wear in the field. Then the powerful Cat C27 ACERT engine block is mounted and secured within the heavy-duty steel-cast mainframe, creating the heart of this giant dozer. Mounting this engine requires synchronized lifts to handle its 13-ton mass safely. Hydraulic lines, pumps, and valves are connected next, enabling load-sensing implement hydraulics that will later control the dozer blade and, if equipped, the ripper, allowing tilt, pitch, and lift, all in one go. After that, the operator cabin is installed. The cab frame is lowered in, ergonomic air-suspended seat placed, fingertip electronic controls wired, and the multicolor display panel mounted so operator can monitor engine and implement status. Finally, the heavy moldboard dozer blade or ripper attachment is bolted on. For blades, hardened DH2 or DH3 steel cutting edges and end bits are fitted to ensure durability in the toughest conditions. The complete machine undergoes functional tests, simulating real dozing conditions. Even minor misalignment in the tracks can affect efficiency and fuel usage. The combined weight and balance of blade and ripper are checked before transport. Operators, visibility and control ergonomics are confirmed to reduce fatigue in the field. This assembly ensures that every CAT D10T2 leaves the plant ready for years of heavy-duty operation. The build lineup moves smoothly. Everything locked in, ready for first fire up. You can almost feel the raw power waiting to break ground. It's fascinating how every heavy component comes together with such precision. KGHM-ZANAM produces machines engineered for the demanding environment of underground hard rock mining. Excavators with bucket capacities ranging from 1.6 to 8.5 meters handle loads between 3 and 16 tons, with heights from 1,500 to 2,650 millimeters and widths from 1,760 to 3,350 millimeters. Watching these machines in action, you get a sense of controlled power packed into every arm. Dump trucks feature payload capacities from 20 to 28 tons, with cargo box volumes of 11.1 to 15.5 cubic meters. Heights range 1,890 to 2,300 millimeters, widths 3,360 to 4,000 millimeters. Self-propelled water wagons carry 3,000 cubic decimeters, while rock-cutting units have booms extending 3 to 6 meters and claw widths of 1.6 to 2.6 meters. You'd never guess such long reach can remain stable underground. Anchor units operate with anchors 1.6 to 2.2 meters long, drilling holes 28 to 38 millimeters in diameter, heights 1,750 to 2,000 millimeters, widths 2,069 to 2,560 millimeters. Fuel and lubrication wagons feature tank capacities from 3,870 to 6,510 liters, heights 2,200 to 2,330 millimeters, widths 2,200 to 2,460 millimeters. This setup feels like every machine knows its exact role, no wasted motion. The self-propelled transport wagon spans 5,900 millimeters in length, 1,850 millimeters in width, 1,880 millimeters in height, seating 13 plus 1. Feels like a fleet of organized giants moving underground. KGHM-ZANAM combines precision engineering, heavy-duty performance, and extensive service capabilities, supporting mining, metallurgical, processing, maintenance, and transport operations. That coordination between human planning and machine execution is oddly satisfying. From excavators to transport wagons, KGHM-ZANAM integrates power, reliability, and versatility in underground mining, proving that each unit is built to endure harsh conditions while maximizing efficiency. Somehow, the whole process looks almost too easy for what it's doing. Northwestern Zambia's open-pit copper mines are a theater of raw power and massive engineering. Machines moving 150 tons in a single scoop feel like giants wrestling the earth. Every day, millions of tons of soil and rock are shifted with precision and speed, requiring some of the largest machinery on the planet. A 260-ton haul truck equals 200 passenger cars lined up, while 360-ton excavators rival fully loaded Boeing 747s. It's almost absurd to see one machine hold that much weight effortlessly. These machines operate continuously, digging, loading, and transporting ores to processing zones, maximizing efficiency. The coordination between excavators, dump trucks, and other equipment ensures the mine runs like a perfectly choreographed operation. Kinda wild how they make mountains move like it's a playground. Through these open-pit copper mines, Zambia demonstrates the peak of mining engineering, combining human oversight with machines that dwarf conventional expectations. This is heavy metal in action, literally. The old Sutton Place HOA Dam in Garland, Texas, stood as a shallow pond for nearly 40 years, gradually filling with silt, debris, and runoff. When a heavy spring rain washed gravel, rocks, and trash into the headwaters, the HOA faced a decision: restore or remove. This removal isn't just demolition, it's reclaiming control over stormwater and safety. Operators position excavators and concrete saws to cut through the dam, carefully exposing the underlying sediment. Sections of concrete are broken apart and removed, while minimizing disturbance to the remaining pond bed. Water flow is gradually restored as channels form naturally through the old pond sediment. Narrow drainage paths develop, and vegetation begins stabilizing the exposed areas. The efficiency here surprises you. The pond starts reclaiming itself quickly. Contaminated sediment is limited to the top layers, and the remaining concrete culvert still holds back the bulk of debris. Each movement balances safety, cost, and environmental impact. Somehow, the whole removal feels orderly despite the scale of work. By 6 months later, grass and other plants cover the sediment, preventing erosion and stabilizing the area. The HOA successfully removed the dam while keeping downstream contamination minimal. This is a subtle but effective example of urban water management in action. The PMA 6040 ACFS in Peru showcases raw efficiency in modern mining operations. Its electric hydraulic system delivers power that once needed diesel engines, now without polluting the air. The loader lifts massive loads with remarkable ease, optimizing material handling in open-pit sites. Operators can maintain a steady cycle time thanks to responsive controls and high torque output. Each swing of the bucket translates into fewer trips and faster productivity. The machine's frame absorbs stress effectively, ensuring stability during peak loads. Advanced traction control allows smooth movement on steep, uneven terrain. Environmental gains are immediately noticeable, with zero diesel emissions improving working conditions. Charging stations are integrated on-site, allowing quick energy replenishment between shifts. The electric motor's regenerative braking feeds energy back, enhancing efficiency and lowering operational costs. Hydraulic systems coordinate bucket, boom, and tilt functions seamlessly, ensuring precise material placement. Cabin ergonomics reduce operator fatigue over long cycles. Safety systems are extensive, monitoring load limits, tilt angles, and ground conditions. The sheer force of the loader makes moving rock and ore almost effortless. Maintenance routines are streamlined, as electric components require less frequent intervention. Kinda funny how this huge machine can feel like it's gliding on invisible tracks. In comparison to traditional diesel loaders, the PMA 6040 ACFS offers quieter operation, lower heat output, and cleaner emissions. This combination of power and sustainability positions it as a game-changer in mining efficiency. Each feature reinforces the final goal, maximizing throughput while minimizing environmental impact.
Observe Orion inching along jungle tracks, rollers, and workboats coordinating seamlessly. Stretching 74 meters long, 15 meters wide, and 14 meters tall, this 813-ton vessel is far from ordinary. Every structural joint of Orion is engineered to withstand immense stress during transport. That sheer weight alone makes every maneuver feel like orchestrating a small army, The teams mobilize the workboats Multicat Argus 1 and Booster Station Energy 3, carefully aligning the massive dredger on rollers and barges for the journey ahead. Each move is a complex balance of engineering and teamwork. Hydraulic lifts adjust Orion's position, keeping it perfectly stable while heavy transport vehicles guide it along narrow jungle tracks. Sensors and alignment tools ensure millimeter-level accuracy as the dredger moves. It's almost comical to imagine a ship this size threading its way through thick foliage without a scratch. Crew members communicate through radio as the dredger inches forward, its hull gleaming under the Suriname sun. At key moments, support cranes assist with minor repositioning, ensuring that no part of Orion's structure is stressed beyond safe limits. Temporary bridges and reinforced platforms span uneven terrain, letting the transport vehicles bear the enormous load. That pull is stronger than you'd think for a mid-sized machine, and here it's moving a giant like Orion. Despite obstacles like soft ground and sudden curves, the coordinated effort of Dutch mining experts, heavy lift specialists from Mammoet, and Roldock's marine engineers keep progress steady. Each team member anticipates potential problems, making split-second adjustments that prevent costly delays. This is why projects like this take months of preparation. It's all about timing and synergy. As Orion nears its destination, workboats provide stabilization in rivers and crossing points. Deck-mounted winches and booster stations maintain perfect alignment, letting the dredger slide seamlessly onto its final launch position. Kind of funny how the dredger looks almost casual while the entire crew and machine network is pushing every limit. Redundant communication lines keep every operator in sync across multiple vessels. Finally, after a journey that blends daring, calculation, and raw strength, the Orion is ready for operations in new mining sites. Every bolt, beam, and hull section has been preserved, proving the project's thorough planning and flawless execution. Feels like holding controlled power and motion. Each stage of transport was recorded to inform future heavy lift operations. The operation stands as a testament to human ingenuity and mechanical prowess, showing that even the most improbable transport missions can succeed with coordination, skill, and perseverance. Drivers and engineers coordinate closely to test the Tatra 813 8x8 under extreme conditions. Operators adjust suspension settings to maintain traction over uneven ground. That torque doing the talking here. Wheels flex independently, absorbing shocks while maintaining stability. Feels like this truck doesn't waste a second thinking. Hydraulic brakes respond instantly as the driver navigates sharp descents. The trial highlights the machine's durability and flexibility.
Stretching across the road, 6 massive 40-meter concrete beams are prepared for transport by Girder Schwertransport at BFE Erfurt. Each beam weighs several tens of tons, requiring precision handling to avoid structural stress. The steel reinforcement inside each beam is carefully inspected before loading to ensure structural integrity. Seeing these long structures move in unison is oddly mesmerizing for something so rigid. Each beam is carefully loaded onto specialized trailers capable of supporting extreme lengths and weights. Stretching across the road, 6 massive 40-meter concrete beams are prepared for transport by Girder Schwertransport at BFE Erfurt. Each beam weighs several tens of tons, requiring precision handling to avoid structural stress. The steel reinforcement inside each beam is carefully inspected before loading to ensure structural integrity. Seeing these long structures move in unison is oddly mesmerizing for something so rigid. Each beam is carefully loaded onto specialized trailers capable of supporting extreme lengths and weights. Escort vehicles lead the transport, signaling to nearby traffic and providing guidance for tight maneuvers. Traffic coordination teams verify that local traffic signals align with transport schedules. Radio communication between escorts and drivers ensures split-second adjustments for safety. It's fascinating how human judgment and heavy machinery interact flawlessly on such delicate operations. The transport slowly snakes through industrial zones, overpasses, and local roads. Each beam's weight and length require careful steering adjustments and constant monitoring of load distribution. Operators check suspension systems continuously to prevent trailer tilting under uneven terrain. Operators communicate constantly via radio to maintain coordination across all 6 transports. Contingency plans are in place for unexpected obstacles or sudden weather changes. Even minor shifts could have compromised safety or alignment. Girder's team completes all 6 transports with efficiency, highlighting the combination of specialized equipment, experienced operators, and detailed route planning. These operations underscore the value of preparation, teamwork, and technological solutions in moving extraordinarily large construction components.